Hey guys, here are notes for 7.3 and 7.4, and it's about the slope formula, which you've already learned about in your Algebra 1 class. Probably even in 8th grade, you probably saw about the slope formula, but we are going to review it because it does come into play when we're talking about vectors. So yeah, the slope formula I have right over here, y2 minus y1 over x2 minus x1. The y2 minus the y1 is basically what we did up here when we did a vector and we did the change in the y. So that's our rise change. If you look at the pointer right there, it's the change in the y is the rise. And then the x2 minus x1 is the change in the x that we used for our component for the vector. So that was the x change down here at the bottom. So for a vector, we would go over 5 and up 5. Therefore, the vector would be, the component form would be 5, 5. This was back from our last example. The slope of this line, however, is you rise 5 and you run 5. So 5 divided by 5 would be a slope of 1. So it has a component form of 5, 5. It has a slope of 1. So basically, you're going to put your y component over your x component. That's what this is, the y component here, the x component here, to get your rise over run. So that's going to be your slope. So I'll just review a couple of these things. It says you name a vector using the components of the change in x and the change in y. The y component of a vector is the change in y is the rise. The x component of the vector, and this x component here is the change in x, which is the run, and the ratio rise over run is the slope of the vector. The letter m is used to designate slope. So this was the example that we learned. So this has a component form of 5, 5, and it has a slope of 1 because 5 over the 5, the rise over the run would equal 1. All right, let's do a couple here. It says graph each vector on the same coordinate plane and find each slope. So if I was going to graph this first vector, I would grab this and I'd go over -1 and up 4, -1 and up 4. It's my initial point, and then my terminal point is 4, 0. So I go over 4 and up 0. So we need to find the slope of this vector. So let's draw in the vector. The vector is an arrow that has direction and magnitude. So there's the direction of the arrow. The vector itself is to go over 1, 2, 3, 4, 5, and to go down 1, 2, 3, 4. So the component form of vector would be the vector would be 5, 4. So that's the vector itself. The slope would be the y over the x. So the slope would be the 4 over the 5. So you have a slope of 4/5. Your component form is 5, 4. Your slope is 4/5. So that would be for the first one. That's how they work. Okay, so the component form would be over 5 and down 4. Oh, I'm sorry. I just got my own mistake there. Down 4, so it's -4. So your slope is a -4/5, which makes total sense because the line is a downward line, so it's definitely a negative slope. So that's how you would do A, B, C, and D. And actually, the slope I had set up to put over here. Okay, so your slope for letter A, this is the vector right here. And then your slope is -4/5. Okay, so try these on your own and then see if you can get them right. I'll pause it and do them and then put it back on. Okay, well here they are. Hopefully you guys had a chance to try them on your own. Letter B, the vector was 0, 6. We went over 0 and up 6. So it was change in y of 6 over change in x of 0. 6 over 0 would be a no slope. Do not have a slope on a vertical line. You can't have a 0 on the bottom. You can't divide by 0. The letter C was a horizontal line. It was over, way more than 2. My bad. It was 1, 2, 3, 4, 5, 6, 7, 8. Oh, you know what? I messed up. That was a 2. It was a 2. Sorry. I put point G at the wrong place. Point G should be right here. So it's over 2. There you go. There's the vector. And G goes right there. So it's over 2 and up 0. So 0 over 2, the change in x over the change in y, 0 over 2 would be 0. And letter D, it just says its initial point is 2, 3. And the vector is over 3 and up 1. Over 3, or no, over 1 and up 3 would be the vector. Over 1, up 3. So the slope would be basically the change in y, 3, over the change in x1. So it'd be 3 over 1 slope. So that's just a slope of 3. Draw a line with a slope of 3 passing through point A. All right, let's find point A first. Point A is the point -2, -5. Oops. -2, -5. And if I want a slope of 3, I need to do rise 1, 2, 3, and run 1. And I should probably do it again. Rise 3, and run 1. Rise over run, rise over run, rise over run, and so on all the way up. Your line would look like this. That line would have a slope of 3, and it would pass through the point -2, -5. That's how you can use your slope to draw a line. If you know a point, and you know the slope, the slope is like a map telling you how to get to the next point. You're starting at -2, -5, and you're going to go up to 3 and over 1. Rise over run if you make the slope into a fraction. Medical instruments should be sterilized for 10 minutes at 140 degrees Celsius. The machine that sterilizes the instruments has a graph of -1/2. How long should instruments be sterilized at 135 degrees Celsius? Okay, so 10 minutes, 140 degrees. That would be our first coordinate. So let's make a point at 10 minutes. So let's see on the bottom. Let's see. 1, 2. Let's do like by 2s. 2, 4, 6, 8, 10. Let's do 2s there. So this will be 10 minutes right there. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Will be there. 2, 24, 26, 28, 30. Will be right here. Alright. So let's check it out. 10 minutes, 140 degrees. So 10 minutes, 140. Right there. And it's got a slope of -1/2. -1/2 slope. That means you go down 1 over 2. So down 1. So let's see what we got. 35, 36, 37, 38, 39, 40. Okay, so we go down 1 degree. You go over 2, so that would be 2 right there. That's 2 minutes. So down 1 over 2. So if we went down 1 again, and we went over 2, it would be right there. Down 1 over 2. Okay, how long should instruments be sterilized at 135? It looks to me like down 1, 2, we're almost there's 140, 139, 138, 137, 136, and 135. So exactly 20 minutes. So you could draw in your line there. And you could see that 135 degrees would be at 20 minutes. That's got a slope of down 1 over 2. Now, this looks like down 1 over 1, but my scale on the bottom here is 2, 4, 6, 8, 10. So really I'm going down 1 and over 2. Down 1 degree over 2 minutes, down 1 degree over 2 minutes. So that would be the slope there, down 1 over 2. Linear equations. Leon uses a pump that fills a tank at 10 gallons per second. Before he started, the tank already contained 500 gallons of fuel. You can show the relationship between the amount of fuel in the tank and the time the pump runs with a table, a graph, or an equation. So here's the table. Let's fill that in first. Let's see. All right. 0 would be 500. I just lost one of my numbers. Okay, why are we doing this now? Where did my 10 go? Okay. 0 seconds would be 500 because that's what it started. It says it started, the tank had 500 gallons in it. So before it even started, it gets 10 gallons for every second. So at 10 seconds, 10 times 10, that'd be 100 gallons. So it would be up at 600. So for every 10 seconds, he'd be going up another 100 gallons. So this would be 700. And we'd have 800. And we would have 900. So those are all points that we could graph. So let's draw those. All right, so we're over 10 minutes, or over 0 and up 500. And then we're over 10 and up to 600. Okay, over 20 and up to 700. So you can see the linear equation there. This one is not going to go into the negatives at all because we're not going to have negative gallons. It's the pump is working, the pump is making positive gallons, so we're not going to have negative gallons. All right, so then that's one way that we can show a slope. We're going to go up 100 gallons for every 10 seconds. Here's the graph of it. And then we have the slope-intercept form, which we could make an equation where m is the slope and b is the y-intercept. So let's see, our equation could be something like y equals our slope is up 100 gallons over 10 seconds. 100 divided by 10 would be 10x, and then plus 500. 500 is your y-intercept. 500 is where it touches the y-axis, right here at 500. So 10x plus 500 right here. So now it says how long will the pump run to fill the tank to 3,000 gallons? So how many seconds x would it take for the y to become 3,000? So with an equation we can just plug that in. 3,000 equals 10x plus 500. And then you subtract your 500 on both sides and you divide by 10. So subtracting 500 would give you 2,500. And then dividing by 10 would give you 250. So it would take 250 seconds for it to fill the tank to 3,000 gallons. So more than 2 minutes. No, more than 4 minutes, sorry. 240 seconds would be 4 minutes. Okay, the point slope formula is another easy equation to use. You take the y minus your point, y1, and equals, that's m, times x minus the x point, or x1. So if I had a slope of -3 and I wanted to make sure this point was contained, my equation, I would put y minus minus the y point, which right here is a 4. So y minus the 4 equals m, the -3. They gave us m. M is right here, the slope. And then parentheses, x minus the x, which was -3. Okay, so that would be your formula. Then all you got to do is, to get your equation, is just simplify that. So you'd have y minus 4 equals, and that would be -3x. And the double negative right here is going to become a +3. So -3 times +3 would be a -9. And then you would add 4 to both sides. So you would get y equals -3x. And -9 plus +4 is going to be a -5. So 3x minus 5. That would be your equation. When you're given a point and a slope, it's really, really, really easy to find the equation if you know this formula, if you know the point-slope formula. Parallel slopes and equations. So it says find an equation of a line parallel to this line, y equals 2x plus 3, and goes through this point. I'm going to use the same equation. I'm going to take this y minus y, see if I can make this work. I'm going to use the same formula right here, and I'm going to plug in the new point that I have. So y minus the y of my point is 4 here, so y minus 4 equals the m. Well, where's the m? Where's the slope? Well, it's right there. Parallel lines have to be the same slope, so it's going to be a 2. And then it's going to be x minus the x we have here, which is -2. So again, you've got a double negative, so really this is a +2 in here. So first you distribute your 2, so you're going to get y minus 4 equals 2x, no, -2, no, 2x. 2x, and then 2 times 2 is going to be 4 plus 4. So 2 times x is 2x, 2 times 2, positive 2 there, is going to be 4. So you add 4 to both sides, you're going to get y equals 2x plus 8. What that does is that's a line that's going to be parallel to 2x plus 3 because they both have 2x, but it's going to touch the y-axis at 8 where this one touches the y-axis at 3. So it's going to be parallel. Perpendicular slopes in equations have opposite and reciprocal slopes. You check by seeing if they multiply to give you -1. That's how you really check it. But again, we use the same exact formula. We can still use the point-slope formula. The point they gave us is right here, still -2, 4. You can see that I'm using the same point there. So it's still going to be y minus 4 equals an m. Okay, this time m was 2 because this one was 2. This time we need to make it a -1/2 x. And then that's our -1/2, and that's our slope. And then it's going to be x minus the x that they gave us is -2. Again, it's going to become a +2. So let's first distribute. So we get y minus 4. You're going to get -1/2 x. And then -1/2 times a +2 is going to be a -1. So it's going to be -1. Again, you add 4 to both sides, so you're going to get y equals -1/2 x is still there. And positive 4 and negative 1 would be a plus 3. Okay, so if I want to get a one perpendicular to this line that goes through this point, it's still going to be a plus 3, but now it's going to be a negative 1/2 x and not a positive 2x. Perpendicular slopes are opposites and reciprocals. Okay, the last one is about a scatter plot. Now I'm going to pause it here in a second, put all the points in so you don't have to watch me put all those in. But a scatter plot can help us see if there's a relationship between the data. A line of best fit can be drawn that represents the data points. So here's an example. The table here gives a latitude of certain cities and their average temperatures in January. I'm going to make a scatter plot. So I'm going to pause it right now. You can make your dots if you're using the blank paper, or you can just wait. But I'm going to pause it and put in the dots. All right, I'm back. Here are your points. I put in a red line of best fit, which kind of an arbitrary line. You could kind of choose kind of where you would like it to go and what equation you'd like to use. Now in this case, a line of best fit, usually you try to have as many dots below the line as you do above the line. So here I've got 5 dots below, I've got about 5 above, and 1 kind of on the line. So I kind of just chose that as an arbitrary line of best fit. Could swing up or down a little bit. If this is what I consider my line of best fit, then my equation would be to go down 5 and over 20. Down 5 and over 20. So down 5 and over 20 would reduce to a negative 1/4 ratio. So negative 1/4 slope, down 1 and over 4 x, and then I put plus 85 because that's the y-intercept. That's where it would touch the y-axis. There you go. We'll see you guys later.